Hello, I'm Marie Gilbertson, and today I'm going to walk you through my infographic, Can Florida Panthers Prevent the Next Pandemic? So as I'm sure many of us have experienced during our current COVID-19 pandemic, it can be incredibly difficult to predict how a virus, especially a new or emerging virus, will transmit in a population. So to try to improve our ability to predict these transmission events or predict transmission of novel viruses, we started by asking the question, can common viruses that do not cause clinical illness predict how related but deadly viruses will transmit? If so, these common viruses that affect humans and all animals, they could potentially help us to prevent the next pandemic. To address this question, we looked at a naturally occurring system, in this case, the Florida panther. So Florida panthers are an endangered subspecies of mountain lion found in southern Florida, and they're affected by a couple viruses that are really relevant to this question. The first virus is called feline immunodeficiency virus, or FIV. Now, this is a virus that's common to panthers, but doesn't actually cause clinical illness. It's transmitted by close contact, like fighting and biting. Our other virus of interest is called feline leukemia virus, or FELV. Now, this virus causes severe disease in panthers and was the source of a major outbreak in 2002 to 2004. This virus, like FIV, is transmitted by close contact, like fighting, biting, and even grooming. So our objective with this project was ultimately to determine if rules of transmission for FIV, which doesn't cause disease, could also predict transmission of FELV, which does. So our first step was to simulate FELV transmission based on these FIV rules of transmission, and also compare that to three simpler types of models. So for our FIV model, we first analyzed a whole bunch of FIV viral genomes from panthers, and those findings found that transmission of FIV is mostly by adults and two individuals that are close by. So we could simulate FELV based on these sort of rules of transmission. We then used these other simpler models to compare predictions. So we used a random model where transmission occurred between random contacts in a network. We used an overlap model where transmission occurred based on the distribution of overlapping panther home ranges. And we used a well-mixed model where transmission occurred randomly in a well-mixed population. Our next step was then to compare the predictions from our different types of models to the real FELV outbreak. So over here on the left, these are kind of the descriptions of what really happened in the observed FELV outbreak. So there we saw that it was a long, slow epidemic. There were about 5 to 20 individuals that were severely affected, and we also observed some weak spatial clustering. And so when we look at our model performance, really all of our models did about the same at capturing that long, slow epidemic and the number of individuals that were severely affected, but only our FIV model was able to capture that weak spatial clustering. So it was a really exciting finding. A caveat here is that most of our models are actually wrong. Only about 10% of the models were basically on target for those observed FELV dynamics, but honestly, that's probably just because there are a lot of unknowns about FELV transmission. We had to explore all sorts of different types of parameter space, and so it's perhaps not surprising that most of our models were not on target per se. But ultimately, what we are finding and concluding here is that our non-disease causing virus, FIV, is in fact showing promise for predicting transmission of an analogously transmitted disease-causing virus. And so it's really exciting and deserves to be explored in other systems as well. And ultimately, more accurate predictions from these models could probably be facilitated by linking modeling and laboratory research to reduce uncertainties about those transmission parameters. So a great opportunity for modeling and lab work to really integrate, collaborate, and work together. So with that, I'll wrap up, and I thank you for your attention.